I'm Manon. I'm the manager of the Tanis Innovation Center. First, a bit about Tanis. So Tanis is a machinery builder for the confectionery industry. We have a main focus on gums and jelly production lines, and we are all one-stop supplier. So we produce the kitchens to make the candy masks, the depositors to deposit the candy in the shapes, the drying rooms and the finishing machines. So you can just enter your ingredients to our machines and the final candy will be ready for your packaging line. Today we are here at the Tanis Innovation Center, which is located in the Netherlands. Our headquarters are 2 buildings away here in the same street. And the Innovation Center we have here is to support all our customers or prospects. So we can do benchtop trials, pilot trials, validate new recipes, but also validate upscaling or moving from a certain kind of production to a new kind of production. Welcome everyone to this knowledge sharing on Fondant, the Tanis crystallizer. What is Fondant? So Fondant is a sugar paste and it's a saturated sugar solution. So there are a lot of sugar crystals in the solution and they are not all dissolved, so they are super separated. And Fondant is known for its very creamy texture due to the very small crystals. Now, super saturation, we all know this graph now, I think. If we look at 70 degrees C, 3 parts of sugar fit in 1 part of water. But if I cool down this mass again to 20 degrees C, then not all the sugar fits in the water anymore and it wants to crystallize back into its crystal state. And that's what's also happening during the fondant process. So the crystals want to get back in their crystal shape and we make sure they are very tiny to achieve this very creamy texture. Why do we use fondant? So fondant is used in a lot of confectionery application. Fondant on its own for cake decoration, it's well known. You can buy it in the supermarkets, but also a lot of different bakery products like the tompoes and the chocoladebol. They are also covered with a layer of fondant, which you can always flavor or color as you like. In sugar confectionery, we see it used a lot as an ingredient in chewies. So in high chews, chewies are based on a crystallization, and to make sure this crystallization has a very nice smooth texture, you like to add the fondant as an end crystal. So you add small crystals, so the rest of the crystals also want to be small. That's also something we do in candy canes, candy corn, and in a nougat, for example, or a fudge. You can also add a fondant as a crystallization agent. If I just go to Google and I type in fondant and I look at different fondants, the top one you see 88% dry solids and you see only 3 ingredients. So water, sugar and syrup. These are the three ingredients you need to be able to produce fondant. But if you look at other fondants, you see more ingredients can be added. Stabilizers, acid, preservatives, but also fats. So to give it more creamy or to keep it flowing over a longer shelf life. Because the sugars crystallize out, there is also a watery phase. So you can bind that with a kind of hydrocolloid or add some preservative to it. So you see also different kinds of fats used, hard fats and soft fats, and of course some acid and flavors. You see the dry solid content ranging from 87 to 91. That's the area we are playing in talking about fondant. The Tanis crystallizer. So with the Tanis crystallizer you can produce fondant. And how does this process look? The first step is always cook the sugar mixture to high dry solids. The crystallizer is not evaporating anymore, so the final dry solids of your fondant need to be added in the beginning. Also, it's very important that all the sugars are dissolved. So if I have one big remaining sugar crystal, that can end the rest. So I have a lot of big crystals and that doesn't give me the creamy texture as I like. So what's the most important for the cooking step? It's dissolving all your sugar crystals and make sure you have the right dry solid content before entering the crystallizer. Step 2 is putting this hot sugar mass through a Tanis crystallizer. And what do we do there? It's mainly cooling, so we cool the mass down, and by mechanical force we make sure only small crystals can form. And this is how the process looks in a process flow diagram. So mass is entering the cooker, cooked to the required cooking temperature, flash off because we want to remain at very high temperatures. If we would cool down here too much already, we have already some crystals which are formed. So we want to make sure here everything is still in solution. Then we go into the crystallizer, we cool the mass down, we have the mechanical force, and then the product is ready for the next step. On this crystallizer, we have 2 cooling sets, which can set to a certain temperature. And I will show you in the more detailed drawing how the cooling is executed. So cooling is the most important thing by the crystallizer, and we have 3 things to cool. First one is temperature. We enter mass from, for example, 130 degrees C, and we want to cool it down to 80 C, so a lot of temperature needs to be removed from the sugar mass. We have a lot of electric energy because we have the mechanical force with this big engine. So also this energy and from friction we need to cool again. And we have crystallization energy. Forming crystals also provides energy, so we have to cool that as well. And the last step can be adding additives like a fat or cacao powder or a flavor, so you can blend it in the fondant. Now, how does the Tanis crystallizer look? We also have one downstairs in our pilot plant, and here's the drawing of it. So what you see, the candy mass is coming in here, and the fondant mass is coming out from this direction, and then we have the cooling steps. Here you can see it much better. So this is the crystallizer cut half, and here you see the yellow arrow, the mass is entering. The yellow arrow, the fondant is coming out of the crystallizer, and we have 2 cooling sections. So cooling section 1, cooling section 2, and a cooling section on the inside. So the red is the product, and you see the outside is cooled and the inside is cooled. So what are the settings I can play with when I talk about the Tanis crystallizer? Bricks and temperature in, both related because my set point temperature is related to my bricks getting in. I can set the cooling temperature of section 1, and I can set the cooling temperature of section 2. And then I have the rotor speed, so the speed of the rotor moving the candy mass, which you normally want to make sure it's giving the right flow. So you first set this on a certain RPM, so we have a certain flow. And you always watch the amperage. Do you know? Ampere reading. And that's because that's the resistance that the rotor is experiencing. And that's very important because normally you start quite at the 60 degrees C, and then you slowly going to lower the cooling water. And when it's too cold, it gets too much force, so the engine is almost not handling it anymore, and then you go slightly higher. So slowly you're going to cool it, and you have the most mechanical force on it with a certain output and the right cooling temperature. The more resistance I have and friction, the more sure I am of creating the small crystals. So we want to have a lot of resistance there, but not too much for the engine, and that everything will solidify in the crystallizer. So it's very close to get to the right set point. Very slow changing and lowering the cooling sections. And then you can read the temperature going out of the crystallizer. However, this is not a set point used to regulate anything. It's just an outcome of the set points which I have on my cooling sections. Then a few weeks ago I did a session with mechanical engineering and we did a practical session. So test 1 we made 4 groups. Group 1 made the 250 grams water with 650 grams sugar and 150 grams syrup and start boiling. They stopped at 113 degrees C, which results in 85% dry solids. They put it in a bowl with a whisk in a cold water bed with ice, and they just start whisking, because that's the whole idea about the crystallizer. You just start cooling and giving some mechanical force. The second group did the same, but stopped at 180 degrees C, 89 solids, C at 91% dry solid, and D at 93. So question, what do you think that happened? What were the differences? Janne, do you have an idea?
I think the last one is it's more viscous, so it was more difficult to whisk it. And because everything was done by hand, it might have also got bigger crystals because there's less shear.
Sander, would you expect any other things to happen?
Maybe the first one, because of the low dry solids, you don't get any crystallization at all. So it's maybe on the, because it was 86 dry solids where Fondant would start. So maybe that one didn't even work at all.
Very good answers, team. So indeed, 85% dry solids didn't crystallize, so they kept staring for like 50 minutes without any crystals were formed. We saw the 89 dry solids was optimal for crystallization. It really turns out very nicely white from all the crystals that were formed, and the crystals were quite smooth, even manually. 91% dry solids was also still okay, but more hard to mix it. And 93, no crystallization. It just turned into rock without any mechanical force. Then we did test 2. So you see now difference in sugar-syrup ratio. So team A had 650 grams sugar and 150 grams syrup. B had 500 grams sugar and 300 grams syrup. And then the other two, they also have fat, which was mixed in during this cooling step. So what would you expect here, Brian, to happen?
No idea.
Janne?
More syrup helps to make less viscous, so then it's easier to mix, so you get better crystallization, maybe. And the fat makes it a little bit more smooth.
Sander, anything to add?
I don't know. I would think that the first A would work best because you have the most crystal and most chance of getting it done.
Let's see. So indeed, the test A went very well because we did exactly what test 1 was and on the right dry solid, so it worked perfectly. B, with the high amount of syrup and low amount of sugar, we again could keep stirring for 50 minutes without any crystal forms, because the syrup molecules are just in the way for the crystals to be able to form it. And then we saw first, especially for D, the day after, we saw this was more smooth because the fat phase keeps it a little bit more creamy. So instead it becomes very hard and you can really slice pieces from it. This one could still be a little bit full together. So that was the session. Short summary. What is fondant? It's a supersaturated sugar solution with very tiny crystals. We make it with a Tanis crystallizer. The Tanis crystallizer is cooling the sugar mass and giving the mechanical force to form very small crystals, and that's the most important parameter of fondant, is very small crystals, very homogeneous. Fondant is often used as an ingredient in confectionery products, but also for bakery products. any questions. Thank you very much for joining. I hope it was you have some new information.